renders those components. Wherever the change is detected, only those components are rendered instead of the whole web page, which saves a lot of time. Although this is a very small application, so here it won't make a lot of difference. But if it's a complicated, huge application, then yes, it does make a huge impact. So this is your original DOM and this is your virtual DOM. This is your DOM, this is your DOM tree structure.
Say you change 2 elements here. So now this whole tree doesn't need to be rendered because there's these two changed. So React compares both of them, the original and the virtual, and sees that only these elements have been changed. Hence, they are also updated in the original DOM. Moving on to our next question, what is state management in React? Now, state management involves controlling the flow and handling of data within your app to ensure the UI responds correctly to user inputs and data changes. Now, there are multiple types of state management in React. There is component state, props drilling, context API, and state management libraries. Component state is like your use state and use effect. Props drilling is an important and interesting concept here. Here's my React file. Now, if I have a particular message, props drilling is basically passing the message from the parent to the child. Like say if I have a message here, hello from the parent component. Now this is the parent component. We're gonna send this to our middle component. It's going to take a prop as the message. This will be our parent element. And then when you come to the middle component, you will take that message as your prop, arrow function, a development. And now here, this will be my middle component. Here I'll call my child component and pass the message as a prop to my child component as well. Moving on to the child component. Again, we'll be taking the message as a prompt. And here we'll finally be showing the message. Child component, our message, which we brought all the way from the parent component, will be displayed in this particular child component. That is props drilling. Now, in case of huge applications, this becomes a problem because if it's a smaller application like the one that I just showed you right now, it's easier to keep track of the ones that you're using. But if you create a complicated application, then you'll not always be able to remember the order of your components or the layout of or the structure of your whole website, and it can lead to confusion and a whole bunch of chaos. That's why you have context API, which is useful for global state management. Next, we have state management libraries like Redux and all, which is used for complicated applications. Moving on, what are some of the commonly used hooks in React? Now in React, there are a lot of hooks like useState, useRef, useReducer, useContext. But in this particular question, we'll be looking at the 3 most commonly used React hooks. That is useState, which is used for creating variables that can change over time. useEffect, that is used to handle the side effects in a component. Then useContext, which is used to access data from a context in your component. For a better understanding, let's consider an example. All right, now let's look at the code for better understanding. Let me open my React file. I've already created a React file right here. Now, if you don't know, all you have to do is go to command prompt and then write npx create React app and then give any name to your app and press enter. Your React application will be created. Going back to my VS Code, let me remove this middle component and things like that. So for this example, let's just create a timer, a clock timer. right? So other than React, we'll need to import use state and use effect. Use context, I'll show you in another example. For this, let's just look at use state and use effect. I need to create my state here. Time and set time. I'm gonna keep it 0. Then let's call use effect and create an interval. Set interval set time function. The previous times' value will be increased by 1 every 1 second. Then then this function is gonna return. When it's gonna return, it will clear this interval, and in here, let me create an h2 perhaps. Time all right. Now if I start my application, okay, we haven't called it in the app yet. Clock time on. Now you can see it's getting increased on its own. Now that is how you use use effect and use state. For managing the state, we're using use state, and for creating and clearing the interval, we are using use effect. Now let's move on to understanding how to use context. So for this, let's first create our context. For that, let me just create a file called as message context, which will have the message to provide it to the rest of the code, because this is global. So whatever message I'm going to put here, it can be accessed by every single file out there inside this particular React project. So I need to import create context here, and then this will be message provider, which will have this prompt. But before that, I'll need to create the context. So that will be message context, which will be create context. Next, this will be the provider. Let me put my message here, which is, hey, this is create context. All right, now in the return part, message context dot provider, the value will be this particular message, and this prompt will come here. Now we can create another file, display message, which will display this content from the message context. Now in this particular module, I'm gonna import use context, and then here I am going to import my message, which will be from message context. And the next line, we will display the message. Now let's go to our app.js and add it here. Here I'll import message provider because I need it here. And then inside our display, or rather display message. Now let me run it on the browser. I'll have to re-render it. Alright, here is your message and this is the create context. That is, we are importing it from the create context. Not just display message, you can even create other applications. We still have a clock timer. Here also we can try and bring our use context and display it somewhere here. Now if I put the clock timer here as well, this is the create context. It's inside the context file also. That is what I'm talking about. It creates a global context which can be accessed from any file. Alright, so let me stop this and let's move on to our next question. That is, explain the component lifecycle in React. Now, there in the component lifecycle in React refers to the sequence of events that happens to a component from its creation, that is mounting, to its removal, unmounting. Now let's look at these processes one by one. To start with, let's compare it side by side with an analogy so that it will be easier for you to understand. So to start with, you consider a person who just woke up. So that is known as the constructor function. That is the initialization, waking up from the bed. Next, you have the dressing up part, which is known as rendering. That is getting ready to interact with the real world. Dressing up, drinking coffee, or whatever you do before you get ready to meet the world is called as render. And this, if you compare it with your UI UX design, when you design your website so that it's ready to interact with the users, that is called as render. Then you have the particular part where you go to work, you attend phone calls, or you do your job, you code, whatever you do. That is called component did mount. And this whole process comes under mounting. Moving on. Next, throughout the whole day, the person can keep on deciding if they need to change their clothes or if they need to do something new. That is called as should component update. Should a new feature be added? Should a re-rendering take place? And if the person does decide to change a new dress, or does decide to do something new, then you have to re-render the whole thing again. Again, rendering comes in. Next, the person can think about whatever they did throughout the whole day, which is component did update, that yes, the update did happen. This whole process is called as updating. Moving on, we have the last phase, which is when this person goes to bed. You are done with your everyday activities and you're preparing to shut down the whole process, shut down your whole body and your mind. That is, component will unmount, and that is inside unmounting. So to summarize, we have mounting, updating, and unmounting. Mounting is when the component is created and inserted into the DOM, the person waking up, getting dressed, interacting with the world. Updating is when the component's state or props change. Should the change happen? If the change did happen, then render it, and then the change happened, so commit the changes. And lastly, we have unmounting, that is shutting down the whole process. Moving on to our next question, which is what is context API and how is it different from props? So we just looked at how we can create a global state using use context, which is part of context API. And props, we saw that in props drilling, as in how we we're passing the component from the parent till the child, which passed through the middle, parent, middle, and child, and how difficult it was, and then how we solved it with use context, which was a global context, and this is part of context API. Let's look at how these are different in a tabular format. The context API is a feature in React that allows you to share state and data across components without having to pass props down manually at every level. It helps manage global state and avoids prop drilling, where you have to pass data through many layers of components. Now let's look at the table. So the purpose of props is to pass data from the parent to its child components. And the purpose of a context API is to share a global state across multiple components. Data passing in props is explicitly passed down through component hierarchy. In context API, you can access it directly in any component. You just have to use the use context and you can access it from any component inside the same React file. Next, reusability. Components are tightly coupled to their parents, and if you have to call a child of one particular parent, then if you're calling that child from another file, say a parent number 2, then you'll have to call the parent as well to get that child file, because there might be prompts that are passing from the parent to the child. Next, in case of context API, components can be reused as many number of times as you want to, and they're independent, meaning when you're importing one context API, there are no additional prompts or anything that you need to take care of. It's much more clean. Depth of component tree. Props can lead to prop drilling in deeply nested structure, whereas in case of context API, it can avoid props drilling completely. Any child can access the context directly. Setup complexity. Props is simple and straightforward, whereas context API requires setup of providers and consumer components. Context API does take a little bit of time to set up, but once you get the hang of it, context API can save you a lot of time and keep your code modular and very, very neat. Moving on to our next question. How can you optimize performance within a React application? Now, React itself tries a lot with features like virtual DOM and a lot of other libraries. React itself can optimize performance a lot, but there are other things that you can take care of. Like, we have pure component built-in performance optimization. This is like the virtual DOM I talked about, only rendering the particular components that have been changed. That is the built-in performance optimization, like filtering out only the ones that needs to be updated. Next, you have load paths when it's needed. That is code splitting or lazy loading that we talked about when we looked at the Pinterest example. Next, you have optimizing context usage. That is whatever data that you're sharing, make sure to only share the data, only share the particular parts that you need. Like when we looked at the case of GraphQL in that API, we were fetching only the parts that we needed. So when you're sharing, don't share the whole file, just share the particular things that they need. For example, in an API, if you're sharing, don't share the whole body of the API. If they only need the name of the file or the title of the particular item, just share the title. Next, we have remember calculations and functions, that is memoization, like the caching and cookies and session data, temporary data, so that it doesn't have to be loaded over and over again. Next, you have reduce component re-renders, control when components update. Don't go around updating the same component over and over again. You can add new features, but don't go around and keep on updating the components. Moving on to our next question, that is, what do you understand by a higher order component in React? Now, a higher order component is a function that takes a component as an argument and returns a new component. HOCs are a pattern for reusing component logic. Now, to understand this better, let's consider an analogy. So say whenever you go on websites, when you click on a particular link in any particular website, you'll see that it starts loading, like the way it is loading right here. So it will take some time for it to load before the website is finally loaded. So this particular whole part, which when it was loading, that is done by a higher order component. How? Let's look at a code. Now you can see this particular code where you can return a new component and add your logic here. Now, if you consider the loading code in this particular format, you can see that with loading is loading and props is the pre-existing state. So now here you have the loading function if isLoading is true. That is, if your website can detect that it is loading, that means isLoading is true, then you will display the loading scene. Else, you can go into the main component, which is the wrapped component. And then you can go around and show the main component right here. That is HOC. So if isLoading is true, it will keep on loading, and the moment isLoading becomes false, your website will be displayed. And this isLoading function is called as a higher order function, which is used within another function. So in summary, a higher order function is any function that you use inside of a function. Like this loading thing is very important inside this website, because when you're transitioning from one web page to another web page, you need some kind of connector there. So that's why you need to fill in with a function. So that's why it's called as a higher order component. Moving on, we have our next question. How do you handle forms in React? So when you think about any forms, Google Forms or any kind of forms, there are three main important things that you need to keep in mind. That is managing the form inputs, how your user, what kind of inputs your user is going to send to you. Then capturing the user inputs. There should be a field so that your users are able to input their values, whatever values they need to put in the form. Then you need to be able to store this user input. Then you need to be able to respond when they give you the data, store the data, then you manipulate the data, then you have to respond to it as well. Let's understand this with our code. So let's move on to the code part here. Let's create a new form here. I will need to import useState in this particular form. Alright, I will have input value and set input value as my useState, which is, I'm just gonna set it to 0 right now. Then I'm gonna need two functions, which is handle change which will set the input value as e.target. If you have worked with JavaScript, you'll know this one. Then you have handle submit, which will obviously handle the form once it's been submitted. Let's do e.prevent default, which will prevent the default submission behavior. We'll put form has been submitted and here's your data. Let's just put the value of input value here. Now inside of this function, div function, let me just put form, which will have on submit, you'll call handle submit, and inside of this I'll create a label for input. Input type is text, name and value and ID, let it be. Value will be input value. On change, handle change function will be called. That's the label one. And then let's create a submit button. Submit. This is how you handle forms. Now this is for taking single input. You are creating a label in here. So you're taking an input inside the label, and the value is input.value, which will take the value from the user. So we're fulfilling the three main criteria with this particular code. The first part where we're taking the input from the user. Second part, we're processing this with the handle change. And when the user clicks on submit, we are handling the submit part as well. But this is for single input. There's just one input field right here. What if there are multiple input fields? So for that, inside the handle change function, So here in the use state itself, you'll have to change everything. Instead of one particular element, you will have to change it to form data and set form data. And here it will be, say, if I have name and email, I'll leave space. So instead of this, we're gonna have to change a lot of things. Like right here, we'll have to put const name and the value, and this will be e.target, and we'll have to set the form data as the already existing form data plus the name, which will be set to your value. And then we'll have to update the form data here as well. Okay, don't get confused by the name here. This is just, I can change it to something else also. I think the name will be, you will get confused with this name. That's not it. It's just if any item, say if this is name or this is email, then that its value will be updated in the form data. Now the already existing form data, this will also be appended. So here we need, this is the name field. This will be form data dot name, and we'll need another label. This will become the name label. This will become the email. Type will be email, and handle change. And that is how you handle multiple inputs. Alright, so now you know how to manage the form inputs, how to create user forms, and how to respond to form submissions regardless of a single field or multiple fields. Let's move on to our next question. What is server-side rendering and how is it beneficial? Now there is two types of rendering. One is client-side rendering, that is rendering the information after my local server has fetched the data from the original server. And the next one is server-sided rendering, which is already delivering to my my local system a rendered web page. That is in this original server itself, the file will be rendered and then it will be delivered to my particular local machine. Server-side rendering is a technique where a web page is rendered on the server before it is sent to the user's browser. Instead of sending a blank HTML file with JavaScript code that builds on the page of the server on the client, the server generates the HTML with content already included and sends it to the browser. That is already, everything is defined, everything is rendered, and then that particular data comes to your local machine. That is SSR or server-side rendering. Now, an amazing example of this is your Times of India website. If you go to that website and you try to scroll down, you'll see that all the data is preloaded for you. How is that happening? That is called as server-side rendering, because all the data that you're looking in front of you, that is already rendered. It's not rendering after it reaches you. It has already been rendered and then it reaches you. This significantly reduces your page loading time. Then another example of client-side rendering is your social media apps like Instagram. Although Instagram does uses CSR and SSR together, the first interface that you see of Instagram is server-side rendering. But once you start scrolling, it's client-side rendering, because based on your user activity, you will be suggested that kind of reels which you want to watch at that moment. So that is client-side rendering. Now the benefits are that it has a faster initial load. Since the HTML is pre-rendered on the server itself, the browser can display the content quickly, improving the perceived load time for the users. Next, better search engine optimization. Since when it is listed down on search engines like Google and all, if it is already rendered for you, then the search engines can look for certain keywords inside the website. Now, since it is already rendered, it is already there on the website. Hence, it is easier for the search engines to locate certain keywords. Search engines can easily index the content of server rendered pages because they don't need to execute JavaScript to see the content because it's already there. Next, improved performance. Since most of the rendering is done on the server, client don't need to do as much work to render the page, which is helpful for users on slower or less powerful devices. Reduced interaction time. With SSR, users can interact with the content more quickly because they don't have to wait for the JavaScript to fully load before seeing anything. Moving on to the last question we have for React. What do you understand by Redux in React? In React, components manage their own internal state, but as an application grows, managing shared state between multiple components can become complex. This is where Redux helps by providing a single global state that any component can access. This comes under state management libraries that we discussed in the previous questions. For understanding Redux, we have to do the whole code. So let's get into that. All right, let me open my code editor. Here it is. Before starting, we need to install a couple of things. We have to install the Redux library. So let's do that. While it gets installed, let me just tell you quickly what a Redux actually is. So I am sure you must have heard of this deadlock situation where one resource waits for another resource. So Redux is exactly something like that. It tries to solve that issue. So consider this analogy that there are a lot of chefs working in a particular kitchen. Now they all have separate ingredients. They all have separate knives and forks to cut vegetables and do things like that. Now, if one particular chef requires a particular knife and it is with another chef, they have to wait for this first chef to finish using that knife so that they can get it. And sometimes there is a chance that this knife might get lost, and this other chef who was waiting for the knife, they might never get the knife at all. So that is why we need Redux, so that it can centralize all the resources at one particular place so that every other component can access it. Now, in case of Redux, Redux collects all these resources and puts it in a common particular store, say a particular place which is called as the store. So let's create our store, which will be called as counter reducer. Now, React has this particular feature where it collects all the resources and puts it in a common warehouse. And that warehouse or that particular store is being guarded by a manager. There's a manager for the store who makes sure what kind of resources to give, when to give. So that is this counterreducer.js file. Next, you need to create the main file where the warehouse where it will be stored. So let's create that. That is our store file, store.js. That is called a store in Redux. Now we'll have to import a couple of things like configure store we need. Next we need counter reducer, which we just created. Counter reducer. Next, if somebody tries to access your store, let's configure that. Let's just put out the resources there. Let's just define who is the manager of the store, and that is counter reducer. Export default store, and that's it. Now we need to create an action. Now action creators are like when a particular, coming back to our warehouse example, and our manager is standing in front of the warehouse managing everything, and then somebody has to access a particular resource inside the store. Now for accessing that, they need to create a particular kind of slip or maybe a paper in which everything is written that we're gonna make a website with this example in which there'll be two buttons, an increment button and a decrement button. So if you click on the increment button, the value should increase, and if you click on decrement, the value should decrease. So that is our action, that okay, I'm going to give the action that increment and the value. There'll be two parameters. So that is what the action is, the paper which you give to the manager that this is the action I need to perform. So we'll need to create that action.js file, inside which, like I said, in our website, we'll just be creating two methods, that is increment and decrement. So I'll create increment, which will have a certain value. Like I said, the type of the action, what I need to perform, and the resource that I'll be giving. Okay, this is my resource, you do whatever you want to do with this. So when I give the resource with the type action, I want the type will automatically become, when it's written increment in my action, in my paper, when I give the paper to the manager, it's written in increment. That means the type of the action I'm requesting for an increment type action, and the payload is basically what is contained inside your action, the value that you're giving, that is payload. And the payload is this value that I will be specifying in this particular function. Same I have to make for decrement as well. Decrement. Okay. Next, we can move on to the app.js file, where we'll be creating use selector and use dispatcher. Let me just write that first. Use selector and use dispatch. We also need increment and decrement one from our actions. Now, use selector and use dispatcher, the simplest example that you can understand will be, say, if you consider the example of Amazon's web page. If you say if I create an e-commerce website of my own, then I'll have a particular JSON file in which all the items that I want to display on my website will be stored, right? So retrieving that data from my JSON file and showing it on the website is done by use selector. Now, when my user interacts with my e-commerce website, when my user click on add to cart or remove from cart, that kind of request, that the user is sending, is managed by use dispatch. Moving on. I hope that made the difference clear between both of them. Now, we need to create a function called as count here, which will be used with use selector. It will have a already existing state.count. Okay. Then the dispatcher will come, which is use dispatch. Counter with redux. Here we'll display our count. Below this we'll have our two buttons. This will be the increment button, and we'll have an decrement button as well. So whenever you click on this, we'll call the value, the parameter which we have defined, this increment with the value. This particular value is 1. We'll be dispatching that, okay, a user has requested for something. I told you dispatcher is whenever the user requests for something. So when the user clicks on the button, we'll dispatch immediately with the value 1. This is not supposed to come here, this is supposed to come here. And we will have to do the same thing for decrement as well. Now this is not enough. We are left with one last step, which is the connection point. We have to connect Redux with our application. For that, you will have to go to the index.js, there it is. And here, instead of this React strict mode, we need to replace it with provider store. We have our own store. Let's close that. I'll remove this. Store, we will have to import. Alright, that is done. Alright, we didn't do one very important thing here. If you go back, we haven't set the state yet. So let's do that. So the initial state, we're gonna keep the count for the initial state as 0. And counter reducer, when it's called, the by default state value will go and it will have the initial state and there will be an action. Alright, moving on, we'll insert a switch case which will define what to do based on the actions type. So there can be the case of increment. Whenever that happens, you have to return the already existing state, but the count will increase by 1. The same thing for okay, don't worry, VS Code. Happy? All right. -1 will happen. Then there will be a default case where you'll simply return the state and do nothing more. Now, if you look at this particular code, you can see our initial state is here. Click on increment. That was all there to know about Redux. Moving on to the next component, that is Node.js. In this particular module, we'll be covering 10 questions. So before we start with this, let me just walk you through how to create a server using Node.js. Let's call HTTP. We don't need that. We need a port. Then we need to create the server where we'll be taking request and response. Rest dot writing something, we'll be sending the status code as 200, it's fine. Then we'll be setting the content type as plain text. Then we can end the response. Then we can listen our server on the port that you have selected. Let's log that. Server listening on port. Then if I try to run this code, and if I open my localhost 3000, it is listening on this particular port. Now, Node.js and Express.js are very closely related with each other. So if we have to convert the same code to Express.js, we'll have to change a lot of things, starting with this. You'll have to first call Express, and for this you'll have to install Express as well. I've already installed, so I'm not going to install it again. And you will have to require it here. Then you need app, where you'll be calling Express. Port remains the same. Instead of creating the server here, we'll have to do app.get, getting the root page, request, response. Let's send something. We can remove this and it will be app.listen instead of server.listen. If I try to run the same code again. Okay, let's try to run that. And it's again hello world. Those are some of the changes between a Node and an Express module. Although in the course we have broken down Node and Express into two different modules, most of the times both of them are very closely related.
Just a quick info, guys. Intellipaat offers a full stack web developer course in collaboration with iHub IIT Roorkee. Through this course, you'll learn tech stack like MongoDB, Express.js, Angular, Node.js, along with HTML, CSS, JavaScript, and more from the IIT faculty. With this course, we've already helped thousands of professionals transition into high-paying developer roles. You can check out the success stories on our Achievers channel, whose link is given in the description below. No doubt this course can take your career to new heights. So check out the course page link in the description and take the first step towards becoming a certified full stack web developer.